Hey, this is Nathan from DRT Ammunition, or Dynamic Research Technologies. Today we're going to do a quick demo to showcase our 79 and 55 grain 223 or 5.56 round. What we do is we make a powdered core technology bullet. We take that powdered core and put it in a standard copper jacket. We get 4 major features from it. 1, it's lead free. 2, it's frangible, so it's shoot house safe, but at the same time it's penetrating frangible, so it's going to go through the same things that your normal lead duty rounds will. Except for something organic. The third big feature, it's more accurate, it's more stable than lead, and it's not as malleable when it comes out of the end of a muzzle, so we're able to get better BCs and better accuracy at distance. And then lastly, the most impressive feature are the terminal ballistics. So what we've got today is some common barriers. We've got AR500 steel to show the frangibility, 1/2-inch drywall, insulation 1/2-inch drywall, so an interior house wall. We've got 1/2-inch particle board, so an exterior house wall, or a barn, something of that nature. And lastly, we'll shoot the ballistics gel. So here we go. With this 79 grain here, we're able to walk right up to steel targets, be safe, or shoot house safe because of that. We get about a 2-inch flashback typically. So in addition to being safe for shoot houses, this is incredibly safe for urban environments. So if you are working in a, in a city or something where you're going to pull a shot, or you're worried about carrying your weapon downtown, and you do have to shoot, this is going to be a much safer alternative to that. Interior wall here, we're just looking for the reaction in a single hole in the back. So you guys can see from the backdrop there, single impact. Same thing here with the 1/2-inch particle board, single hole, single exit, single impact on the back wall. So we'll take some time, shoot some ballistics gel now. So this round comes apart or becomes frangible in 2 circumstances. 1, if it hits something harder than the jacket itself. So something hard enough to make lead ricochet. The other example is when it hits something organic. So watch the gel. Three stages. The bullet's coming in, you see the delay. This first stage here, the jacket rips off, very clear. Then the core is exposed, and that core expands, and when it expands in a huge way. Perhaps we had a small little piece of powder exit this, but nearly 100% of the energy was dumped into that target. It's also important because the likelihood of having a pass through a lot lower. So if you're working in the law enforcement community, clearing a house, something like that, and you have to take a shot where somebody might be behind it, it's a lot safer. So the difference between these two 223 rounds that you're looking at here, the 79 grains on the top, as you can see in the color, that round has more tungsten in it. The 55 has more copper. Now when we go up in weight in a round, we don't actually make the bullet longer. We change the powder makeup inside, so we use heavier powders. Also, we're not changing the size of the wound cavity because we're not really changing the volume of what's in there, shredding. So around, it's not as heavy, you're gonna have a little bit less energy, but you're not actually typically getting any less of a permanent wound channel. So you guys can see as you look at those, very similar in performance.
Amazing, I gotta say.